So, I'm going to talk about statistics today, statistics in SQL Server. And the topic of the session is statistics, an unreliable friend. And I've been thinking about the topic, and maybe it should be SQL Server, an unreliable statistician, because that's really what it's about. And I will show you during the presentation what I mean with that. A few words about me. My name is Magnus. I live in Sweden, where I work as a SQL Server consultant in my own company. I was given the MVP award I don't remember, I think it was October last year, which was kind of surprising and humbling and fun. And I guess the reason is because I do some SQL community organizing. I've been involved in a couple of virtual conferences. I'm involved in the Swedish user group, and I run an event every Friday, which is SQL Friday lunch session. I have my contact details on here. If you want to use the demo scripts, or even, I mean, the presentation doesn't contain much, to be honest. It's this slide and maybe one more. But if you want to use the demo scripts that I'm using for something, then look up Transmocopter with a K, on GitHub, and you can download this presentation and all my other presentations on there. So, why the agenda for today is, first, why did I create this presentation, which I will tell you, and then the rest will be demos. Only demos. I have had a couple of more PowerPoint slides when I've done versions of this presentation before, but I always run out of time, and I think showing with demos is much more worth than running through slides. So why did I create this presentation in the first place? Well, I was working with a system. I was the database developer or database architect in a project. And what we were doing was gathering financial information, financial securities, mostly debt-related ones, into a database. We were gathering from different sources, and then on quite early after we got all the information into the system, we had to do a preliminary reporting to the European Central Bank. And we had this massive view to create this report, and we ran it from some fancy .NET code, but that's not really important. The important thing was that running this report was really fast. It took like half a second, always except for when we actually needed to run the report. And at that time, we got really poor performance. It could take hours to run the report. And we were always kind of short on time to start running the report. It had to be in, let's say, 12 o'clock in the middle of the day. And we wanted to start running the report at 11:55. Because we had so limited time to, audit the data streams that we got in and gather and kind of collect and decide what's the most truthful version of each variable that we're going to report on. And then when we ran into performance problems with the report, we were late with the reporting. And then the ECB were unhappy, and in the end, people started telling me your database is slow, and I was unhappy. So I started looking into what the reason was. And the reason in that case was something called the ascending key problem, which we will look at in detail in this presentation. And we will look at some more statistics and cardinality estimation related topics. But when I started giving this presentation, or the first version of this presentation, was all about the ascending key problem. And Microsoft has put in a lot of work in the cardinality estimator to work with the ascending key problem. If you don't know what it is, don't worry. I'm going to define what the ascending key problem is. But so they have put in a lot of work, and some of it has been really successful, and some of it maybe less successful, which we will also take a look at in this presentation. So without further ado, let's skip to demo. And the demo that I'm going to do, which will be actually the rest of the presentation, because my last slide is the sponsor slide again. And so we're going to look at the nature of our problem. We're going to look a little bit into how we can examine SQL Server statistic to see the cause of our specific problem. And then we're going to jump into looking at possible solutions to overcome the problem that we have. And then in the end, if we have time, I have a demo which is not related to the rest of the demos, or at least they don't tell the same story. But a demo to demonstrate how the cardinality estimation has changed prior to SQL Server 2014 and what happened after that, which I think it's very much related to the main topic of the demos that I'm doing. So I think it's worth looking at that too. So before I continue, I should have, of course, started with this. Marcin, you just go in and interrupt me if there is anything that is strange or odd with my audio. I think it's okay. We have tested it, but it's a new presentation platform for me. So
it's okay.
So let's jump into the main topic of today, which is demos. So let's start looking into the demo database that I've created. I call it Stats Demo. It's a very, very limited database. It contains a few tables, and I'm not even going to use all of them. The main tables that we're going to be interested in today is the table sales.order header, which contains just a few columns. An order header ID, of course, for the primary key, a date, customer ID, which is a foreign key to the sales.customer table, customer address table, which is a foreign key to the sales.customer address table, and yeah, some more header information. It's a very, naive version of an order system, but it works very well for these demos. The information that I created this database from is in AdventureWorks 2014. So if you want to run the demos, if you want to download them and set up the same database for yourself, then you will need to have the AdventureWorks 2014 database installed on the same instance that you run the setup scripts. And if you have that, you just need to run the, where do I have it? Right here, setup database script. No parameters, just run it. And you need some disk space, of course, because it's not super big, but it's a few million rows in the main table. So let's look at the nature of our problem. We have this query, which is supposed to gimmick a kind of reporting query. I'm gathering the average discount of order headers grouped by country region code from the locations table. So basically I'm doing a select from sales order header, joining with customer address, and I'm joining with shipping location, and I have a predicate where the order date equals August 24th in August 2016. And this is in my database that I created. This is the last date that I have in the database. So let's run this query. I'm just going to make sure I have the actual execution plan on, and I've turned on statistics IO so that we can look at the logical and physical reads that this query is performing. So let's run this. get the result set, which is not really interesting because all the discounts are the same on every row in my demo database. But what's going to be interesting is looking into the I/O statistics. So we can see that this query is performing, is reading 38 pages from the order header table. We are reading 12 pages from the locations table, and we are reading 17 pages from the customer address table. And each page is 8 kilobytes. So this is kind of to read this from memory, or even if it was on disk, so we had to do physical I/O, would not have been the end of the world. It's not that much I/O. And if we look at the execution plan of this, I'm going to give myself some more space up here. We will see that the execution plan starts up here with a clustered index scan on the customer address table. And if you're just starting with execution plans and haven't really worked a lot with it, you might think, oh, a clustered index scan, I know what that means. That means we're scanning the whole table. And you might think this is probably a bad idea. In this case, it's actually a pretty good idea because this table is small. It's only 5,626 rows. And as we could see here, those rows fit on 17 pages. So scanning through them is going to be a quick operation. And the same thing with this index scan that is performed. We're scanning the whole index from the locations table, which is not the end of the world either. It's 12 pages that we're scanning. And then a hash match is combining the information from the customer address table and the locations table. And only when this information is gathered, SQL Server is reading from the order header table, which when I write the query, if we look at the query code, we're starting with the order header table. The execution order, the actual execution order is different because SQL Server figured that it's going to be smarter to start gathering the information from these small tables and then just join in the information from the order header table, which is 12,500 rows that we're reading from the order header table. And the alternative in this case would have been to start with reading the order header table, and then for each row in the order header table to make a lookup into the customer address table and to make a lookup into the locations table. That would have been 12,500 lookups, which would have cost much more CPU and worst case physical I/O, but at least logical I/O reading from ROM. So this is an execution plan that I am pretty happy with. And it ran in basically no time at all. So if we now go on and we create some orders for the next day in the month. So I have this little stored procedure, which is just generating 12,500 rows into the table. And then we run the exact same query, but we change the predicate to 2016, August 25th. Still quick, but it's quick because the relatively small amounts of data, my computer is quick, it has all the data in memory already or in the buffer cache. But if we look at the I/O statistics, we will see that instead of, I can't even remember, it was something like 38 logical reads from the customer address table. No, the order header table is still 38, sorry. Locations table used to be 12 in the previous execution plan, now it's 25,000. For the customer address, we have 50,000 logical reads. So now we're starting to talk about some amounts of data that has to be read from the ROM memory, the buffer cache, and actually processed by the CPU. And I'm alone on this instance now. I'm the only one running this query. But imagine it's a multi-user system and people start running this at the same time. We're going to run into CPU contention pretty quick if we have these kinds of execution plans. So let's look at the actual execution plan then. It starts with an index seek on the order header table. And if you look here, you see some information. It says 12,497 rows of 1. So what this means, if you read the execution plan, is that SQL Server is estimating 1 row to be returned, but in reality 12,500 rows were returned. If it would have been just 1 row, this execution plan would have made a lot of sense, because 1 row from order header, and then an index seek to get 0 or 1 rows from the customer address table, then a key lookup to get some more information from the customer address table, which is not included in this index that we're seeking in, and then 1 lookup into the locations table. I mean, that would have been pretty okay, I would say. But now when we got 12,500 rows back from this first operator, we're doing this lookup 12,500 times, doing this key lookup 12,500 times, and then we're doing this clustered index seek 12,500 times. And then we have to do a sort operation, because we're doing some aggregation, and the aggregation operators like data to be sorted coming into it. So the sort operator, as you can see, it has a little warning sign. This means this sort operator, it estimated to get 1 row, but it got 12,500, so it didn't get a big enough memory grant. Then it has to go down to tempdb to sort the data. And that's going to mean, in worst case, even physical I/O to happen. And then the stream aggregate. This is an example of a kind of poor execution plan. For 2 queries which are extremely similar, the only thing that differs is the predicate. Order date equals 25th, or order date equals the 24th of the same month. So what can be the cause of this problem? Well, the cause is this. We need to look into statistics that SQL Server has gathered about our index or our table. In this case, the order date column. And we have an index ix_order date on the order date column. So we can look at that index and the statistics for it. And to examine statistics, there are some management views which they were implemented in some recent versions of SQL Server. But I'd like to make my code compatible with also older versions of SQL Server, because you never know when you need to examine statistics. So I'm going to use the good old command dbcc show statistics. And it takes 2 parameters, the object name, the table name that I'm going to examine, and the name of the statistics object that I want to examine. So let's run this and see what it returns. It gives me some header information. First of all, the name of the statistics object, when the statistics object was updated, and you can see that it was updated today at 11:45. But you were here in the same room when I added rows to it, and it was after 11:45. Number of rows estimated to be in the table is roughly 3 million, and the number of rows sampled when I updated the statistics last time was also roughly 3 million. So if these numbers are exactly the same, well, that's going to mean that you did an update statistics with a full scan, meaning I scanned the whole table and got a perfect picture of the data contained in the column that I was interested in. So let's move down to histogram part of the output, which is this one. And the histogram, it's going to contain information about the key value, the leading column of the index in this case, which is going to be a date, the number of rows which are between two steps. So let's say, how many rows do I have that has a value which is between, not including, the 20th of December and the 19th of December. In this case, I have 0 rows between those two dates, and then the number of rows which matches exactly the key value for the order date. And then distinct range rows is going to tell me how many distinct values do I have between two steps in the histogram, and so on. So if we move down a couple of steps, we see that we have a gap here, 21st of December and 23rd of December. In that case, we have 12,500 rows between two steps. This is not the cause of our performance issue. The cause is, if we go down to the very bottom, we will see that the last step in the histogram is the 24th of August 2016. And you remember when we ran the query that gave us a bad execution plan, we were querying for August 25th. This means we are querying for a value which is outside of the histogram. And when SQL Server is creating an execution plan for any query that you run, it's going to examine the available statistics it has, possibly even update the statistics prior to the query is run, depending on your settings, how much data has been changed in the table since last time you ran a query. And it's going to take a decision. And the decision it's going to take, it's going to be based on this information. It makes no kind of progression guesses or anything. So even if I got my my statistics updated a couple of hours ago, SQL Server has no intention to find out, did I add any information after the statistics was updated? It's just going to look at when did I update and how many rows were changed since the update. And if it wasn't that many rows, it's going to stick to the histogram and try to come up with an execution plan. I should have added initially, I'm running this database right now in SQL Server 2008 compatibility level. We're going to upgrade it during the demo session to more recent versions and see how the optimizer changes its behavior. But for now, we're on 2008. I know it's not strictly supported, but I know also that tons and thousands of clients are still using SQL Server 2008. So I think it makes sense to start with not the newest version. And I also want to say that the behavior that we are looking at now, it's also in SQL Server 2012, which for another short while is going to be an extended support. So it is supported. Let's move on. So we have looked at DBCC show statistics. That is, and you can run it using with histogram as an option. And what you will get in that case is only the histogram and not the header information. So this can be useful if you want to examine maybe take the output and put it into a temp table or something. Then you need to run it with histogram to make sure you only get one result set back from the command. So now we know what the problem is. We know the cause of the problem, and the cause of the problem is that the statistics is not updated when we run our query. And I'll start saying that one possible solution, and then we can just go home and say, let's use this, would be to always update the statistics before you run a query. But that's a kind of bad idea, because we don't want to scan more than 3 million rows every time we run a query against a database or against a table. So let's see if we can come up with some more clever solutions. So IO on set statistics time off, because we don't really need to see the CPU information. So write database, we're turning on the actual execution plan so we can see the execution plans. And my first thought would be, let's parameterize the query. And in reality, if you have, let's say, a .NET application running a query against a database using, for example, the SQL client.SQL command object, then this is what it's going to do, because you will not concatenate the date into the string. You will use a parameter object in your .NET code. And this is what it will translate to when .NET is querying SQL Server. It's going to parameterize the query. So basically the query will look like this. So instead of hard coding the order date, we have a parameter, and then we execute the statement with sp execute SQL. The statement is our SQL string, which we defined above. Then we define the parameters, and finally send in the parameter values. This is how .NET is going to execute your code. And it's going to do it even if you run with, let's say, Entity Framework, God forbid. But if you use Entity Framework, it's going to be the same story. Entity Framework is going to use sp execute SQL to execute SQL commands. So let's run this. We set the date to August 25th, which was our problem date. We examine the execution plan, and we see that we have the same crappy execution plan that we got when we hard-coded the value. In messages, we see that we have the same crappy IO statistics, which will give us a performance problem sooner or later when we add users to this system. So that didn't work, not out of the box at least. So, and what's worse, if I now change the parameter value to August 24th and run the exact same query, we're going to get the poor execution plan with the parameter value, which used to give us a good execution plan. So what's the reason behind that? Well, the reason behind that is something called parameter sniffing. What it means is that when SQL Server sees this, just the whole query, including the comments and everything, it's just text to SQL Server. SQL Server is going to create a hash out of that text and then look into its plan cache to see, do I have a execution plan for exactly this query? And if there is already an execution plan in the plan cache, it's going to reuse it. So when I ran this query with August 25th as the parameter date, I got a new execution plan. It's stored in my plan cache. And the next time I run the same query, even with another parameter value, SQL Server is going to reuse the plan, which is not going to be any better for this parameter value or any other value for that sake. So in this case, this actually made things worse, which was exactly the case with the report that I was telling you about when I started the presentation. Because what had happened to us was that we had changed a number of rows, or maybe we updated the statistics at night. So when SQL Server ran the report at 11:55, it looked in the plan cache, saw that it had an execution plan for the query we wanted to run, and figured out that, there's been an updated statistics since I created this plan. Let's throw it away and create a new one. Statistics weren't updated recently enough to give us a good plan. So it threw out a good plan and gave us a really poor one. So that may happen when you deal with parameter sniffing. We could do something else which is making the code look ugly, but in a way cheats SQL Server into not knowing the parameter value. So what I'm doing is instead of just doing order date equals parameter value, I'm doing order date equals the result of the call to demo.getSameDateScalar with the parameter as a parameter. And this is a scalar user-defined function. We can have a very quick look at it. Alter function demo.getSameDateScalar. And it's probably the most simplistic and stupid function we can think of. It takes a parameter, a date. It returns a data type. And the only thing it does is to return this parameter that it gets. But prior to SQL Server 2019, when the optimizer sees a scalar user-defined function, it's going to have no idea what the function does, because the function is executed in another thread, and it's optimized on its own. I see a question here which I just need to answer. I forgot to have the chat open. God forbid, are you referring to the quality of SQL that Entity Framework is generating here, is the question. Because I kind of said God forbid when I mentioned that you may run Entity Framework code. And yes, it's the quality of the SQL, but it's one more thing. If you just run with Entity Framework with the default options, you're going to get the serializable as the transaction isolation level, which is probably overkill in 99% of the cases. And you're going to get lazy loading, which I'm not going to go into detail, but look up lazy loading. If you don't do anything about Entity Framework, just run it out of the box, you're going to get really crappy performance. Not only because Entity Framework is generating funky SQL code, but also because the default options of Entity Framework really sucks. Enough of that. So the scalar function. What this will do is to make SQL Server just know that, okay, this is a scalar function, it's going to return a date. I have no idea what date it's going to be. So then SQL Server is going to create an execution plan which is based on an unknown value for the date parameter. And then it has no use for the histogram, because if it doesn't know the value of this parameter, it's not going to have any use for a histogram, because it can't look up the value in the histogram. Then it's going to look at the average density for the leading column of the statistics object. So the density is basically how the relation between the number of distinct values and the total number of rows for the table. And it's going to make some calculations based on that. So let's start with running this code and look at the execution plan. And we see that, yes, indeed, we got the decent execution plan, and we can look at the I/O and see that, okay, we're back to 38, 12, and 17 instead of 38, 25,000, and 50,000. Good. But if you leave this code like this, and then 1 year later, a new developer joins your team, and makes some amendment, maybe we need another column in the result set, and then that person is going to look at this line of code and think, why do we call this function? Because this function is stupid, it's just returning the same date. This where clause is, we can just refactor it and remove the function call, and then you're going to go back to the poor execution plan. So yes, this works, but it's not really a good practice to write ugly SQL code. Something we could do in SQL Server 2008 and SQL Server 2012 was to use a trace flag 2389. And a trace flag in SQL Server is a behavior that you turn on or off, kind of a toggle feature toggling. So let's turn on trace flags 2389 and 2388. What they do, 2388, that one is just going to change the output of the VCC show statistics. So 2389 is really the interesting trace flag here. What it's going to do, I'm going to start a script to have it running while I'm talking, because it's going to take a few seconds. And then I'll explain why I'm running it. So what the trace flag 2389 does, it looks at the leading column of a statistics object every time you get the statistics update. And it records, was all the new values the same or higher than the previously highest value in the statistics object? It records a yes or no, and then if it gets 3 or 4 consecutive statistics updates where you have increasing values for the leading column of the statistics object, SQL Server is going to mark this column, the leading column, as ascending, and then change the behavior of how it executes queries in the cases where the leading column value falls outside of the statistics histogram, which is exactly the case that we have here. The script that I was running was doing an update statistics, adds value for a new date, update statistics, adds values for new date, etc., etc. So if we now look at the statistics object, we have, we can't see the histogram, which is by intention. See, trace flag 2388 changes the behavior of DBCC show statistics to be able to display this thing. Leading column type equals ascending for the most recent statistics update. This means that it has been marked as ascending, and now SQL Server is going to treat this table, or this, the optimizer is going to behave a little bit differently from before. So now we can again add, let's do this first. Let's try with the with histogram option. And as we can see, we can't get to the histogram if we have trace flag 2388 enabled. And I just wanted it enabled to show that we have it marked as ascending. So I'm going to switch off this trace flag, and now we can see the histogram again. So if we scroll down to the very bottom of this, we see that the most recent or the latest date that SQL Server knows about for order date is August 29. Now let's gimmick the same behavior that we had before. We add orders for the next day. And just to make sure that I'm not fooling you, we're going to look at the histogram again. See that SQL Server still has no idea about August 30 that we just added. So the exact same situation as the beginning of this presentation. And now we run the query again. And now we get the good execution plan that we wanted all the way, with the good I/O statistics. The reason for this is doing the exact same thing as calling a scalar user-defined function in the predicate. It makes SQL Server optimize the query for an unknown value for the parameter date, order date, but only if the value, the parameter value, falls outside of the statistics histogram. So if it can find the value in the histogram, it's going to optimize for this value that it actually finds. But here it couldn't find it in the histogram, so then it used the density of the leading column instead. Good. But warning, the trace flag is switched on globally. So it's going to change the behavior of all your other queries as well. So in SQL Server 2008, this is one of the options you have. And it is an option, your only option, if you can't change the SQL code, which is sometimes the case. It could be a third-party system and you have no access to the queries. In that case, this is the option you have to go for. Trace flag 2389. But we're going to switch it off and explore other possibilities. I'm just going to check with trace status to see that I don't have any trace flags on. No, I don't. Good. Oh, the Voldemort solution. This is actually the solution, my first solution. I'm not even going to want to call it a solution, but my first attempt when I ran into this situation was to create a SQL Server agent job, which looked with DBCC show statistics with histogram for my the column that I had in my predicate. Then looked at the highest value, and then looked up into the table with a count and a group by to see how many rows do I have that have a higher value than the highest value in the histogram. And if the statistics was off by more than 500%, then I would do an index rebuild. So don't do that. It's very much a brute force solution. There are better solutions. One could be, let's try it, we could upgrade to SQL Server 2014, and in this case I'm just bumping up the compatibility level of the database. I'm going to run the same query that I just run, which is going to query a date which is outside of the histogram. So let's run it. Messages. Oh, it's a decent plan. 38, 17, and 12. But it's going to be different from our SQL Server 2008 plan, the plan that we wanted to get, because SQL Server is starting with an index econ order header, and it's very strange. It's estimating 1,775 rows, which I'm not going to look into the histogram. I just know that there is no information in the histogram about this date. And the estimation now is going to be 1,775. And let's see, we have 15 minutes to go. I think I will be able to show you what this estimation comes from. And otherwise, you can look it up in my in this demo script, ce.sql. But a hint is it has to do with the new cardinality estimator that was introduced in SQL Server 2014, which was supposed to help us, but in some cases really weren't that helpful. We were lucky this time because this estimation, 1,775, was high enough that SQL Server decided that I'm going to scan the customer address table. But it was more, if this table would have been slightly bigger, let's say double the size, chances are that SQL Server would have reverted to a lookup and another lookup and a key lookup, and we would have had the poor execution plan that we saw with the ascending key problem previously. So let's upgrade to SQL Server 2016. Test the same query. Same behavior. So same plan in 2016 and 2014. And we could probably skip SQL Server 2017 and go directly to SQL Server 2019. And what I'm going to show you is that the behavior hasn't changed in this regard between versions from SQL Server 2014 to SQL Server 2019. And this all has to do with the new cardinality estimator that was introduced in SQL Server 2019. And chances are that you, if you're responsible for a SQL Server 2014 or later database, that you do what I normally do when I create a new database. I right-click, or I script this, but I right-click, I choose properties, I go into the options, I wait for a while for the options to actually appear, and then I go down to database scope configuration, and I choose legacy cardinality estimation on. This means that SQL Server is reverting to the old cardinality estimator because I have found that it's less troublesome to have that one. The really poor thing for us is that trace flag 2389 has no effect on SQL Server 2014 and later, even if you choose to go back to the legacy cardinality estimation. That's not very fun, but that's life. We can't do much about it. We will have to figure out something else. So one thing we can do is to use a query hint. But remember what I said, if you don't have any control of the queries that are run, you can't force a hint. Actually, you can. You can use a plan guide, but that's a topic which is outside the scope of this presentation. So let's assume we can affect the SQL code that is executed. And what we will do, we run our good old query. We have seen it a couple of times now. And then we add option, optimize for parameter dt to be unknown. This is going to give us the behavior that we had with, calling a scatter user-defined function to force SQL Server or the optimizer to optimize for an unknown value. There is a query hint for it. And I prefer this solution much more to calling a stupid function which does nothing good. And that actually costs something to call as well, but that's another topic. So let's try to execute with optimize for unknown. The messages first. Good IO statistics, 38, 12, and 17. That's what we want. And the execution plan is back to the execution plan that we were looking for back in SQL Server 2008, and which is still going to be the best execution plan and most reliable execution plan. Scan customer address and locations, hash match, and seek into order header and the hash match, and then the aggregation. And no stupid sort operator that could cause a spill to TempDB. So is optimize for unknown a silver bullet? No, but it will be helpful in many cases. And the reason why it can be helpful is that the times when it is helpful is when the data distribution inside your table is very even. Because optimize for unknown is going to look at this parameter, and regardless of the value, it's going to give you an execution plan which is kind of the average number of rows, regardless of the value. So if you have a very uneven distribution, on the other hand, so let's say you have an order database and you want to query for specific customers, and you have one customer which makes up 80% of your orders, and then you have 10,000 customers who only ever made one order. Well, then you don't want to use the optimize for unknown in every occasion. In that case, if you know anything about you have your own hunch of the estimation when you write the SQL code or in your application, you could use a trick to just inject a comment into the code. So let's skip this one. So when I call it with an order date, which I expect to return few rows, then I could inject the comment low, That will give me one execution plan. Then when I call the same query, but with an order date where I expect lots of rows to be returned, I could change this comment to high. And what SQL Server does is to look up the hash of the whole text for the SQL query, including the comments. So if you have different comments but exactly the same SQL code, apart from the comment, you're going to get two different execution plans. So that's kind of a trick to cheat server into creating two different plans for different scenarios. But then you need to know in your application, you have to have some special treatment for certain values to inject this comment. Otherwise, if you don't know the data distribution, then the best you can do really is either have your statistics updated. Maybe if it's a report query that you don't run that often, you can do option recompile to recompile the query every time. That's going to be a costly operation for a complex query. So if it's a query you run often, then this is out of the, you can't do this. It's going to cost more to recompile the query than to actually execute it. So the answer, as always, is how do you solve bad estimation problems? Well, it's going to depend. And in this case, optimize for unknown, if it's a useful option or not, it depends on your data distribution. Even then just go ahead and use optimize for unknown. That ends this part of the demo. So I just quickly want to run into a cardinality estimation demo, which is very much unrelated to this one, but let's start here. I'm going to create a table in my database, which I call cars. I'm going to create some rows for it. And the rows I'm creating is Volvo S40 with the color red, Volvo V70 with the color blue, Saab 9.3 with the color black, and Saab 9.3 with the color red. So we have three variables. We have the brand name, we have the model name, and we have the color of cars. Let's switch to SQL Server 2012 compatibility level to begin with. We don't need to run to care so much about these. I just want to run them to have auto-created statistics for my queries. And now, let's say I want to know how many cars have the brand name equals Saab. Well, it's going to be quite easy for SQL Server to find out. It's going to look into its histogram and see, do I have anything called Saab? Yeah, I do. And it has a number of rows. So let's execute. Look at the execution plan. Sorry for this. Execution plan. We have an estimation of 796, and the number of rows returned was 796. Good. So that's a perfect estimation. Same thing is going to be valid if we query for a specific color or a specific model name. But let's think about this. Brand name is Saab and the model name is V70. I know Swedish cars more or less, and I know that Saab never created the model V70, so I would estimate 0 rows. SQL Server knows nothing about cars, of course. Server can only look at how many Saabs do I have, how many V70s do I have, combine these estimations and make one estimation for the query. And let's look at it. It's going to be, I'm going to run it so we see the estimation directly on the operator. It's estimating 511 rows. And that's probably a mathematically correct assumption. It's just that it's very, very wrong, because there are in fact 0 rows with brand name Saab and model name V70. So you see 0 of 511. If I query for Volvo V70, we see that the estimation is, this is, I just need to, let's do exec sp recompile po.cars. Force a new execution plan. I could have done with option recompile, of course, on the query. So 5,000 out of 4,489. So this number comes from something as well. Well, it comes from the combination of Volvos and V70s. And we can go on and add predicates for more and more columns in our table. But the interesting thing is, how does SQL Server make the estimation for a query where you have multiple predicates against statistics objects that are different? So you have one statistics object for each column instead of having a combined one. Let's say if you create an index, you can have combined statistics object for several columns. Then it could be easier to just look at the density of the combination of columns. But in this case, SQL Server has to combine the information about the brand, the model, and the color, and just come up with an assumption. So, in the old cardinality estimator, what SQL Server does is look at the estimation for the first predicate. The Volvo, it's going to be 7,000. Set the estimation for the second predicate, the V70, well, that's 5,000. Multiplies these two and then divides by the total row count of the table. And then multiplies with the estimated number of rows for the number of red cars that we had. And then finally divides by the total row count. So if I first run the query, see the estimation, it's going to be 1,307, and in reality it's not an even number, it's 1307.22, which is exactly what I should get here, 1307.22. So this is the formula that SQL Server is using when using the old cardinality estimator. Let's go to SQL Server 2014 for 2 minutes, and then the session is over. I'm running the query again. I'm getting another estimation, which is 1,769,63. And the new cardinality estimator could do one of two things. One thing could be this formula. So it's going to look at the selectivity for the most selective predicate. In this case, that's the color red. It's going to multiply with the square root of the selectivity for the second most selective predicate, and then multiply with the cubic root for the third most selective predicate, and then multiply with the estimated total row count. That's going to give us this magic number, 1,769. So, back to the orders database for the very funky estimation that we got for the date August 30. We run the query, we look at the execution plan, and we have this estimation, 1,775. And in this case, SQL Server is not using this formula at all. Instead, it reverts to using square root of the total row count for the table. And I haven't really figured out when it does it. It does a comparison of the, column-based estimation and compares it with the square root of the total row count, and it's going to use the lesser of these two values. So square root of total row count is 1,775, which is the estimation we got for this order query. I see a message from Marcin in the chat, so I'm going to check. Probably he's going to say, yeah, he is going to say that my time is up, which is absolutely correct about. There is, I think we have time for 1 or 2 questions if there are any questions. And if there are no questions, thank you, and thank you so much for listening. Don't know how Avatar Land works, so if you're trying to raise your hand, I won't see it probably. So it's probably easier to just type in the chat if you have questions.
So does this approach work against Azure SQL database as well?
Azure SQL database is it's just SQL Server. What you can't do is to turn on trace flags. I think, at least I haven't tried, but it would surprise me because that's an instance level configuration. But you can use the query options optimized for unknown. Is totally available in Azure SQL database. And on Azure SQL database, you're going to get something like SQL Server 2019, but probably with some added functionality, quarterly updated or something like that. Apart from that, it's very similar to SQL Server on-premise. If you're inside just one single database, which is the only thing you can do in an Azure SQL database connection, then it's going to be the same thing with very few variations.
Okay, thanks.
So I see Piotr is typing. Also, just place yourself in top bottom right corner, usually least interesting place on screen. Okay, so let's move myself to there. The reason why I don't place my own picture on the bottom right corner is that the Management Studio is placing the row count of a data set in the bottom right corner. But in this demo, I didn't actually look at the row count from the result set. So that could have been a good option to begin with. Yeah. Thank you. Well, if there is no more questions, I want to say thank you so much for coming to my presentation. I hope that I will get to SQLDay Poland when it's actually an in-person event where we can, say hi, maybe shake hands, have a beer after the presentation. Until then, this is what we have. So, see you. I'm gonna stop sharing my screen, and I wish you a nice rest of the day and a nice tomorrow for the rest of SQLDay. See you.
Thanks.
Sorry, there was a question.
There was a question. Okay.
Where can we find the script?
Oh, right. So let me type github.com/transmocopter. Look for the repository presentations. So it's on GitHub. If you look in presentations, you will have all the different versions of this presentation. We even have the actual link to the actual presentation. Perfect. Thank you, Camille. Now I will stop sharing. See you guys.
Thank you. See you.